When people talk about generative models, they often think of a tool that answers questions. But on its own, a model cannot see our files, open applications, or interact with external systems. That is where MCP, or Model Context Protocol, comes in. In practical terms, it is an open standard that allows a digital assistant to connect in an organized way to external data, tools, and workflows. You can think of it as a universal plug. Instead of building every integration from scratch, it uses a common language that enables the model to understand what it can read and which actions it can perform. How does it work in practice? The architecture is client-server. There is a host, which is the application the user interacts with. Inside the host, there is an MCP client, which connects to one or more MCP servers. These servers provide three key elements. The first is resources, meaning data and content to read, such as files, documentation, or database schemas. The second is tools, meaning functions the model can call to perform actions. The third is prompts, meaning ready-made instructions or workflows. Everything happens through standardized messages, which makes connecting new systems much easier. Another advantage of MCP is that it can work both locally and remotely. A local server can communicate directly with the application, while a remote server can expose the same capabilities over a network. This makes the protocol very flexible, because it allows the model to use real tools and access up-to-date context. For this reason, permissions, controls, and user consent become essential. In short, MCP is not the model itself. It is the bridge that connects the model to data, functions, and external systems in a standardized way. And it is one of the elements making these tools increasingly useful in everyday work.